Hello and welcome to another session on Maven, which is the second session in the Maven series. And if you have not gone through my first session, here is the link for the first session. Please go through the first session. And this is the second session. And this is for all of you who know Maven, who have used Maven, but still want to understand the more internal details of Maven. So what are the things that I'm going to discuss and explain in this video are this. Number one is how you can create a Maven project from scratch. In the last video, or in my first video, what I've shown is if there is an existing Maven project, how you can use that Maven project to compile and to create a package, to install, and what are the different phases, etc. Now here we will see how we can create a Maven project from scratch. Then we will see what is meant by a Maven effective POM, because as we have already seen in Maven that we do not explicitly write the compile, clean, package, install, no tasks. So all of them are actually baked inside, are internally built within Maven. And what we are going to see is how that is internally baked in and how we can actually see that it's actually internally baked in. And third is we will then see what is meant by a Maven dependency tree. Like say, for example, if in a project I have got two external libraries, then I can actually create the dependency tree to know what are the different other libraries which these libraries depend on. So that's something which I'm going to show you in Maven dependency tree. And finally, Maven profiles. So there is a concept of Maven profile, which is also used by some projects, some developers. So it's also good to know about that. So welcome friends, welcome to my session. I'm Shaumik, who is a software developer and architect specializing in backend technologies and I've been working in backend for more than 2 decades now. And in this video, I'm going to make my best effort to explain to you. So let us start with the demo. First, what we are going to do is we are going to create a Maven project from the scratch. And in order to do that, just type Maven Quick Start in your Google window and then search for it. And then you will get a link like this and copy the command from here. And then you need to run the command in your command prompt. So in my command prompt, I have already set Maven in the path. And if you want to know how you can set Maven in path, then I have also created a video for that, which is over there. And you can use that to set Maven in the path. Assuming that Maven is the path, just paste this command. And then it's going to generate the Maven project. It's going to ask for a group ID. I will give a group ID, for example, org.example. So a combination of group ID and artifact ID is basically my unique coordinates of my project. And then an artifact ID, I will probably give test project 1. And version, I'm going to retain that. And package, I'm going to retain that. And I'm going to tell Maven, yes, go ahead and do that. And it has created the project. So, and what's the proof of that? So yes, see, it has created the project test-project1, and I will now open the project in IntelliJ, which is my Java IDE, and show you the project structure. So when Maven creates a project, it creates the entire project structure like the folder structure which Maven expects, like as I've mentioned in the previous video. So Maven expects that under root, there will be a folder structure, source/main/Java, under which the Java files will be there. Similarly, there will be another folder structure, which is under root, and then under root, there will be test and then Java. And under that, there will be any test classes need to be located there. And it has also created the POM here. So this is a very bare bone project, and this app class is a very simple class. This is a very simple class with a single system out println, as you can see. And this is the Maven project. It has created the basic Maven project with only 2 dependencies, which is related to the JUnit. JUnit is required for testing, so that is why it has created this. And then it has added all the plugins. So all these plugins actually correspond to the different phases of the Maven project, like compilation, running, etc., packaging, installation, deploy, etc. So what I'm going to do is, to start with, I'm going to delete all this because this is not really required, and even without this, Maven can function perfectly fine. So I'm going to delete that, and I'm going to run, and so I'm going to compile this project first. You know how to compile the project. Maven compile is the command to compile the project, but before that, I need to set Maven in path in this window, which I'm going to do using So now I'm going to do a Maven compile, which is going to compile. So that's there are only just 2 files, so that's why it will compile and you can see that under target, under classes, it has created this. And if I do a Maven, so since there are test classes, so I have to run another command, test-compile, to compile the test class. The test class is the one which is this one, which is under test. So now it has also generated the test class. See, under test classes folder, it has compiled the test classes. So that is how Maven works, as you have already understood from the previous video. Now, what I'm going to show you is there is a concept of effective POM, which means this is the POM, but how does Maven know how it can actually compile, how it can actually package or install or do all the stuff? So for that, actually, Maven has a concept of internal POM, which is actually the effective POM which Maven uses. For that, I need to use the command Maven and then help : effective POM. So this is the command to generate the effective POM. Maybe what I'm going to do is I'm going to do an output of this to a text file, maybe effective pom.txt, so that we can inspect it better. So now if you open this, you will see that this POM is basically a superset of the POM which Maven originally created. So I'm going to tell you what all those dependencies mean, but before that, let us see that within the build section, it has actually created all the plugins. So all the plugins which were generated by the archetype were not exactly necessary. They were done for a specific reason. And but in any case, Maven contains all the plugins which are required for compiling, packaging, running, deploying, installing, etc. So all the plugins are already there in effective POM. So that is why Maven knows how to do it. And now there is a very important thing which I want to actually explain, which is the concept of dependency management. So dependency management, so there is a difference between dependency management and dependencies. So excuse me. So dependencies are the actual dependencies which will be added to the project. But dependency management is used to, point to a bill of materials. This BOM means a bill of materials, which means this JUnit is actually an umbrella project which contains a lot of libraries under it. So within this dependency management, what we normally do is, say for example, my project depends on a specific umbrella project. In this case, for example, on the JUnit BOM. So if you go to JUnit BOM, what I'm going to see is all the different libraries which are covered in JUnit BOM are mentioned here with their versions. So these are all the libraries which are used within JUnit BOM. But all these libraries are not used by the project. Only these 2 libraries are used by the project. But see, in these dependencies, I did not have to mention the version number, because these 2 dependencies were from within this BOM, from within this umbrella project, and hence it actually knows the dependencies from the umbrella project. For example, this JUnit Jupyter API. Let us see what is the version of JUnit Jupyter API in this BOM, which is, the version is 5.11.0. So that is why it has used that version 5.11.0. So if you click here, then you will see that it has automatically linked to 5.11.0. Because it has got a reference of this BOM. So that is why it's actually a much understated but very, very important best practice of using Maven is, if you are using some big external libraries, say for example JUnit, say for example Spring Boot, or say for example Quarkus or whatnot, it is always better to use their BOM within the dependency management section. Remember, the dependency management section is used to declare the version of the dependencies, version of all the component libraries which are in that umbrella bigger project. So this JUnit BOM contains all the version number of all the sub subcomponents or the sub-libraries of JUnit within the main JUnit umbrella project. And then from that umbrella project, I can actually use a couple of libraries without needing their version number. So this is a best practice. So whenever you are using Maven project, try to always use the BOM within the dependency management, and within dependency, then you do not need to specify the version. And please note that all the dependencies there in dependency management are not automatically added to your project. Only whatever is added within the dependencies will be added to your project. So with that said, let us go ahead and see one more thing, that one more important function is how to actually prove that my project does not contain anything more than these two dependencies. It does not contain all the dependencies mentioned in that BOM. So for that, there is a Maven command of Maven dependency :3. Then it will actually list what are the dependencies of my project. So it will create the tree of the dependency. See, in this dependency tree, it has only shown two things to be its dependency. So see, all JUnit Jupyter, and then this JUnit Jupyter API. So this is the group ID, and this is the artifact ID of one of the dependencies, which you can see here. So JUnit Jupyter API, that is one of the dependencies, and the other dependencies is JUnit Jupyter params, which is this one, JUnit Jupyter params. So these are the two main dependencies. This one and this one, sorry, this one and this one are the two main dependencies which are used by my project. I hope you understood till this point. Now let us go ahead and understand another unique concept of Maven, which is the concept of Maven profiles. Let us take an example, and I'm going to share with you one such example where we are going to add a profile like this. So what it says is, so I have added a single profile which has the ID means production, and this profile uses the Maven compiler plugin. It does some optimization of Maven compiler plugin, which means that what it means is when this profile will be activated, then the Maven compiler plugin will use minimum of this memory, maximum of this memory. So this is the and it will be configured when this profile is activated. So by default, if I am just giving a command of Maven like Maven clean compile, then that profile will not be activated. But in order to activate a profile, I have to give -p and then that profile ID. In this case, the profile ID is prod, so I have to give prod. And if I want to know whether that profile has been activated or not, so let us give that option -x, which prints a lot of information. So then we will see, we can actually verify from the information that these parameters were actually used in the build. So let us go ahead and do that, and then we will verify whether those parameters were used in the build. So here, this fork equal to true, max memory, initial memory. So these parameters were used. So now we can also verify that those parameters were skipped if we do not use the profile. So now we have built without using that profile. This is just an example how we can use Maven profile to do different, or to execute different build paths in different environments. So by default, as you can see, that if we are using this Maven non-production profile, then the Maven compiler plugin will not use the parameters. So let us try to so if I give a output.txt, then it would be easier to find it there instead of finding it from the command prompt. And if I open output.txt and if I search for Maven compiler plugin, for fork is false and those memory parameters are not there. So we saw that how using Maven profile, we actually carried out different execution paths during the build. So I hope you have understood some of the internal concepts of Maven, and that's it more or less which I wanted to discuss in this video. And if you think that I have added value in this video, then please go ahead and subscribe to my channel. Also, please share your feedback here and share it with your friends and whoever who you think would be benefited from this. Thank you very much for your time and have a nice time.